data from Copernicus on how our planet is changing as it warms. And today we're asking a question I think a lot of people ask themselves: when can we blame climate change? And it's a very important question, not only because we want to know how global warming is changing particular kinds of events like heat waves and droughts, but also storms as well. But it's also important because there's a chance that major legal cases against big polluters could be successful in the courts if this kind of attribution science is pushed to its logical conclusion. And remember how it was a massive deal at COP27 when everybody was talking about loss and damage and basically paying reparations from the richer countries to the poorer countries for damage caused by climate change. So it's a political hot potato. It could be a legal nightmare, and it's super fascinating science as well. And here to explain what the science of extreme event attribution is all about are my guests. They're going to help me to understand how it works, help us understand how it works. And please feel free to send us your questions. So let me introduce our guests: Dr. Sonia Seneviratne, who's a professor for land climate dynamics at ETH Zurich in Switzerland; Dr. Frank Kreienkamp, the head of the Regional Climate Office in Potsdam at the German Weather Service DWD; Dr. Sjoukje Philip, a researcher in climate change at the Dutch Weather Service KNMI; Dr. Jakob Zscheischler, a group leader in the Department of Computational Hydrosystems at the Helmholtz Center for Environmental Research, UFZ; and Dr. Samantha Burgess, the Deputy Director of the Copernicus Climate Change Service. Thanks, everybody, for being with us. And please don't hesitate to send us your questions. And can I just say, the scientists don't know this, but we've got a special treat at the end of this live, because the best example of a kind of adaptation I've ever seen to heat wave involving a sea otter. And I really love sea otters. I hope you like sea otters too. Watch to the end. It's great. Or if you're watching on YouTube, you can just skip to the end and then come back for the debate. And there's no waiting around at all. Anyway, we're talking about the science of attribution. Basically, when you can say that a particular extreme event was made more likely, more extreme, or worse in any way by climate change. Sjoukje, that's it, right? That's the basic idea.
Yeah, so the basic idea is to define whether and to what extent climate change played a role. So it's hard to say that it was only climate change if an extreme weather event happens, because extreme weather events have always happened and will always continue to happen. But nowadays it's more influenced by climate change.
Is there a moment, and I'm going to ask everybody really, if they've got a kind of a short anecdote, is there a moment that you had personally when you realized that we could do this kind of attribution, that we didn't need to wait years for everybody to look at all of the data and do lots of peer-reviewed studies, that we could quite rapidly start to draw conclusions?
Well, a really recent event was, of course, the Pacific North American heat wave, where we concluded that such a heat wave wouldn't have been possible in the past climate. But that was only recently. And when I started in 2015, it was really new, this field of attribution science. But I felt straight away that it was now actually possible to have a look at these kind of events.
Jakob, can I go to you? Was there a moment when you realized this was possible and you thought, this is so cool and exciting?
When I started my scientific career 10 years ago, a bit more, it was already technically possible, but it was not so common. And I don't remember really a specific moment where it really changed my mind that this is now possible. From a statistical perspective, it really makes sense that this is doable with our climate models.
Sonia.
Yeah, so I'm probably one of the older here, and I do remember the 2003 heat wave, and I would say at the time probably that was the first event that was for which there was really an attribution study, and I do remember at the time that I guess I was working on my PhD, and among climate scientists we were saying this event seems really quite unusual and there could be a signal in there. But I would say more recently, for me, another very striking event was 2018, because there was at the same time a range of heat waves across the Northern Hemisphere, so in Europe, also in North America, in Asia. And actually we did a study with our group because I thought at that moment it's not possible to have this type of event. We didn't have this type of concurrent event at the same time in the past. I don't remember anything like this. And I thought we would get a signal. And indeed, for that event, we were also able to show that this event actually had a very low probability of happening without human-induced climate change. And I think that's maybe what is particularly exciting now. It's not only about attributing the fact that some events have becoming more frequent, but that some of the events we are seeing are so much outside the variety we saw before that we cannot explain them without human-induced climate change.
Yeah, no, that's really interesting. Frank?
For me, we had a lot of extreme events where we were thinking about, has climate change impacted this event, that has made this event more possible or more intense? But a long time we were thinking, although there are tools in the science, but not tools for a Met service. And then we invited Friederike Otto from the University of Oxford, and she gave us a talk and presenting to us that there are tools, those tools can be used operationally, and then we decided we want to be part of it, we want to learn how it works.
And Sam?
And for me, it was the 2003 event as well. Not so much from a attribution perspective, but from an extreme event perspective. So I was in Europe when it happened, and it was really shocking how outside of the normal range of weather that those 2003 summer heat waves were and the impacts they had in the UK and across France. So I remember really recognizing how maladapted society was to the increase in heat and the implications of that, the increased fatalities and the recognition of the role that climate science could play to ensure society could adapt to weather events like this in the future. And I think that's one of the really nice contrasts when we see the impacts of the 2003 event versus the impacts of the 2019 summer heat waves. The response of the societal response was a lot stronger, a lot better. There was a lot less excess mortality because society was better prepared for these events. So that's a really nice example of how policy has learned from scientific developments as well to adapt society for living in the climate that we experience right now.
I definitely remember it myself as well. It was quite soon after I'd moved to France, and I remember sitting at home in my house, which was a little old house with big thick walls, and it was so hot, and I was sitting there watching Tour de France and thinking, is this what it's going to be like every summer here in France? But it was an exceptional event, and I've heard so many people say that kind of reset people's minds in politics. And from what I've understood, and that they took action on it as well, from what I've understood, that's kind of the goal of this attribution now as well, moving forwards, is to try and start conversations that weren't necessarily happening before. Sjoukje, can you talk to me a little bit about the origins of this World Weather Attribution movement, this coalition that you're part of, and how you're engaging with policymakers and how you're trying to move things forward in terms of the conversation about climate change?
Yeah, so World Weather Attribution Initiative started around 2014 with Friederike Otto and Geert-Jan van Oldenborg. And they just realized that they could actually use their methods as long as they have proven to work. They could use it also for rapid analysis. And they also realized that it's not only the extreme event that they had to look at, but they had to look at the impacts itself and the questions that are actually posed on the ground. And therefore, we now include in all analysis not only the extreme weather event, but also the vulnerability and the exposure of people to this. And the other part they realized then was that we should actually communicate this better. So, of course, we write all scientific papers, but those will not be read by the adaptation and decision makers. So we also work together with communication experts. And nowadays, we can therefore communicate this much better, and via the media it then also reaches the policymakers.
It's certainly the case that when you send out press releases, the media do tend to jump on it. And I suppose the example of the floods that happened in Germany are a good one for that, because it was really very quick afterwards that you were able to come forward and start to make some statements about what had happened. How important is speed? Well,
in the beginning, we thought it was really, really important to do it maybe within a few days. But it turned out that if you already let the media know that you're working on it and you've proven that you can actually do this fast, but maybe not within a few days, then they are willing to wait. So the more important the event was, the more they are willing to wait for maybe a few weeks. Because actually this flooding event wasn't even that rapidly. Sometimes we have events studied within 2 or 3 weeks. And I think this flooding event was a bit longer, but maybe Frank, he led that study. Maybe he wants to
Frank,
jump
you were
in.
involved in that, weren't you?
I had the pleasure to lead this group, but all the persons are doing it. We were 40 people, so we needed 6 weeks. And this was not a fast one, but it still had a lot of impact in the media. We had a huge press calls asking us what we have found in the study, and even several weeks or months after this presentation, we still were walking around giving presentations to several different groups, politicians, saying what is the influence of climate change to this kind of events.
I think it's quite a good moment to go back and have a quick look at a video from those floods in Germany. Let's have a quick look at those, if the director can bring them up, because it shows you the kind of the power of nature and what extreme events really look like is terrifying, particularly as it's here in Europe. And I'm just waiting for Mathieu, the I'm curious about this because in a way, I suppose now we're sort of saying climate change had a hand in this. And when I started out reporting on climate change, that was the last thing that any scientist ever wanted me to say. They go, no, but climate change creates the conditions that allow these sorts of things to happen. There was no way they were going to say that thing. Definitely, there's the fingerprints of climate change on there. Can somebody have a go at explaining to me how we managed to make that leap between those two?
I could maybe mention this because I coordinated a chapter for IPCC in the special report on special report on extreme events, which came out 2012. And then now I was coordinating the chapter on climate extremes, so it is this report. And in the SREC, so again, 2012, our statement was clearly it is very difficult to attribute any single event to basically human-induced climate change. I think that was basically the statement at the time also from IPCC. And I would say there were a few events where there was a clear study that was done, but I think what happened mostly is that the climate change signal became so much stronger. So that's, I think, the main reason why it is different now. I mean, part it's also methodological advance that means that we can do this rigorously with, for instance, a range of different models and observation. But in the end, it's also the signal that has just become so much stronger. I think that's one of the main reasons.
I mean, there in the Altenau region of Germany, you went from a place that was used to having floods, 2, 3, maybe 5 meter floods historically, and they had a 10-meter flood in Altenau where we went to. Is that what you're talking about when you're talking about the signal getting higher?
Well, I'm really mentioning the recent events we had. I mean, if you think of some of those events, which again had a very strong signal, I was thinking, for instance, for the heat waves, clearly we have some events I mentioned before where we can say without human-induced climate change, it could not have happened. And so it's basically this ensemble of evidence. It's also the fact that we can put, for instance, those events in the context of long-term trends. So we have also more years to compare single events with actual observed data. And again, so it's a question of having a signal that is emerging from the noise. And this is becoming basically clearer year after year.
Can I add on this?
Go on, Jakob, yeah.
Yeah, I think one quite elegant. So one way that why scientists thought before it's not possible is because a single event is just a single point in a probability distribution. But I think what people showed with this 2003 event is that you can actually look at exceedance probabilities, and then you have a range of event, and then you can actually attribute, you can really measure the climate change effect. And I think this is the trick that somehow people didn't think about before that, I feel.
You mean the extremes became more extreme?
No, it's more that we are not talking about a single temperature value that is attributed to climate change, but we're talking about a set of events. So all temperature events higher than a certain threshold, and this set of events, this we can attribute to climate change. This
because you're basically able to say that there's no way this would have happened like this, or there's very, very little chance this would have happened like this if we hadn't been pumping greenhouse gases into the atmosphere.
Yes.
Sam?
Yeah, so if I could contribute as well. So where the IPCC reports have always been clear through the years is that extreme events are likely to become more intense and more frequent with a changing climate. So with increasing greenhouse gas forcing, increasing greenhouse gas emissions into the atmosphere. And where the attribution sciences really come in, and where our modeling capability and our supercomputer capability has come in, is the climate scientists can very quickly run an event with a series of climate models, and they change the forcing. So they run the event in a world without any increased greenhouse gas concentrations in the atmosphere, so in a pre-industrial world, and they run the event multiple times in our current climate. And they see, as Jakob mentioned, they see the range of probabilities. So it's not just having one data point, and no scientist would put a hand on heart and say, okay, this is the cause and effect from this one data point. But it's when we're talking about an ensemble of data sets that we have the confidence to say that, you know, the increased greenhouse gases in the atmosphere, the fossil fuel that we're burning has made this event perhaps 10 times more likely than it otherwise would have been if we had a pre-industrial type atmosphere.
Sjoukje, can you talk me through the kinds of things you can do this with? Because we talked about heat waves, and I'm guessing you've got a lot of data points on heat waves, and so you can manage to do it with that. But are there other areas? I'm thinking about storms, for example, where you can't necessarily make the same calculations.
Yeah, so indeed, heat waves are easiest. Same for cold waves, but we tend to forget about them because simply they occur less often. And then, of course, we have heavy precipitation. This is also relatively clear, and this is why we can do a lot of these flooding or heavy precipitation events. A drought is already a bit less common because, or we can attribute less drought because it's you basically have only one data point each year. So a drought occurs often just over a whole year. And this means that if we have 50 or maybe 80 years of drought measurements, that's not that many yet. But this is still possible. But then there's a lot more types of events, indeed winds, but also compound events that are a bit more difficult because, for instance, co-occurring drought and high temperatures. That's, of course, less common than just a high temperature or just a drought. So some variables we can already study in rapid studies, and some others we really need more research, and then we may still able to say something, but then, for instance, not on these short time scales that we are used to in world weather attribution.
Is that because you're basically also lacking enough data points, I mean, outside Europe particularly, or North America, that you don't have enough information or historical information?
That's part of the problem, yes. So especially if there have been no observations for a couple of years, for instance, over Africa, then it's really difficult. And this is one of the problems. It's not just that. So even though the trend may be really clear, if you don't have data, then you can't attribute anything. And models can help, but then you can't test whether the models are fit for purpose because you don't know what to test them with.
I want to bring up one of the maps that's actually about the situation now. And again, this isn't an emergency at the moment, but talking about the kind of winter drought that we've had in parts of Europe. You can see in France and Wales, two countries close to my heart, it's been very, very dry, which might be great if you want to go mountain biking like me, but it's not great if you're trying to grow food, or you're a farmer, or for many other people who want to use water. But is this a thing where we can say there's a climate change link there already, Sam?
Yeah, so I think this is a really interesting map, and this is very much part of what C3S, so the Copernicus Climate Change, does as a climate service. We monitor the climate and share accessible information on the key climate variables like temperature and hydrological variables such as soil moisture, such as precipitation. And what we've seen in the winter period, in Europe in particular, we often have autumnal and winter rain. We've not had a lot of, we had some rain in autumn, but not a lot of rain in winter. So when we look at that map that you just showed, we saw several countries where they're the driest that they've ever been for February and ever been for a 50 to 60 year period, and this is using reanalysis, so it's different to direct observations, but it is verified with direct in situ observations. And what this means is that everyone will remember the drought that we had in 2022 over the summer period, where most of the major river basins across Europe had major implications. It impacted agriculture, it impacted transport, it impacted energy. So a lot of the nuclear power plants, for example, in France needed to be turned off because the water levels in the rivers were too low to cool those power plants. And these rivers are already low right now. So we already know that different ministries across France are putting in special measures to reduce water consumption. And this also means that we're in a riskier situation than we normally would be this type of year, which has implications for the agricultural cycle. So we're in spring right now, so this may have impacts for different crops across these very dry soil areas, and it also may have implications for energy production over the summer months, unless we have significant rain to recharge these dry soils and these low reservoirs and low river basins.
Well, I suppose going back to the heart of the question of that we're trying to address with this event, can you blame climate change when you look at that? Or is that just variability? We're just having a dry winter.
So I think Frank wants to jump in here. From our perspective, we've not done the attribution study. So we would say it would be a combination of natural variability and a climate signal, but maybe Frank will contradict me directly.
No. I was intending to say that we started to work together with hydrologists from France, Italy, and Germany, and we currently try to attribute the low water levels from the last summer. But we do need a lot of information from hydrological models, which we have to prepare before we can use those results. And you also have the problem, if you talk about runoff, you usually talk about influenced runoff by mankind. So not only by the how much water you get, but also you have dams, you have systems which distribute water to different regions. And we try to do an attribution for the low water of the last year, hoping that if we can do it, if we do find the good data for it, that we can do it for this summer again, but we have to test it, or we're currently testing it.
Could we get to the point though where we could be starting to do the kinds of work that is done on extreme events with slightly less extreme events, and actually then how useful is that, I suppose, Sonia?
Yeah, definitely. So, I mean, we can also do attribution for mean climate or seasonal anomalies. Maybe for this specific example, what we know is that we tend to have less rain that is stored as snow now with a warmer climate. So this can be a factor in having a bit less storage in the winter. But on the other hand, in the winter, we tend rather to have an increase in precipitation. So I would say the contribution of human-induced climate change to the current anomaly is probably limited. But where we have to consider this with climate change, it's the fact that we do know that in summer, we do expect more frequent droughts, especially when in Central Europe and the southern part of Europe, which means that starting with this type of condition early in the spring would be quite bad. But yes, in the end, you can do attribution for the mean global warming. You can do this for mean conditions in different regions. But in the end, whether you can answer this type of question is dependent on whether you have done the math. So basically, we cannot look at each single conditions and provide always those numbers.
Good to know having the available stuff and computing power to do it. But fundamentally, also, why do it? I mean, it's interesting. We journalists like reporting about it, but then we, as you know, go on to reporting about something else the next day, and we forget all about it. And I'm sure that's a great source of irritation to you, but it's what happens in the news. Why are you really doing it, Sjoukje?
Because we tend to think that everyone knows that climate change is happening, but actually that's not true. And this is, so whenever an extreme event happens, it's a really good opportunity to show to the people that are actually living there that climate change is happening. And
it's happening where they live. Like
exactly.
This is happening on your doorstep.
Yeah, so it's not always interesting for everyone on the globe, but it is definitely interesting for the people that were hit by this extreme event. And
do you think you managed to change the conversation? Have you changed the conversation about climate change with what you're doing with world weather attribution, do you think?
I think so, yes, because people are listening to us and they are waiting for our reports. So I think definitely that we reach the people on the ground. For every press release, there are people from local institutes that are joining because they really want to know what happened. So we are reaching the people there on the ground, as well as globally, more media and decision makers.
Jakob, can I bring you in? You're an expert in kind of compound events where two bad things happen at the same time, or two not necessarily individually bad things happen, but then they come together and make a bad thing. Can you talk to me a bit about that and whether you can do attribution studies on those sorts of things?
Yes, this is a relatively new field, and we have the same challenges that we talked about before already. That, of course, if you talk about compound events, you need larger sample sizes to capture, to characterize these events for over the historical time period. We need to know whether the models that we are using, the climate models, whether they can simulate these type of events. For that, we need observational data to evaluate them. So attributing compound events is a bit more challenging, but also there we can work with some knowledge that we already have. So if we talk about compound hot dry events, for instance, we know that heat waves become more severe with climate change and more frequent. So everything that we combine with heat will also become more frequent as a first approximation.
You've drawn those conclusions, sort of, then what? I mean, do you go to the local authorities, regional authorities, governments? I mean, you started the conversation, but then what happens?
Yes, ideally, we communicate these results, and people kind of integrate this in their risk assessment. So I think it makes a difference it makes a difference whether we can attribute an event to anthropogenic climate change or not, in whether you should change your risk assessment for future climate risk aspects, right? So if you plan your future, I don't know which types of trees or crops you plant, you want to know whether certain types of extreme events happen more frequently or not. And for this, extreme event attribution can be very useful, I think.
May I pop in? So because especially, for instance, for energy, this is really interesting. So they really are asking us these questions already. So they are waiting for us and these compound event or other types of events. So as soon as we know more answers to these questions, they will actually come back to us.
Who do you mean? Who in the energy sector?
For power plants, or if it's
so the energy suppliers then.
Yeah, the energy suppliers. So if there's no wind and it's cold, then we need more energy. But then what if windmills don't work because it's there's no wind? So that becomes a problem. So therefore, especially cold or the compound events are also really interesting.
We're actually making a program next week about this for broadcast in April, about that question and variability in wind. It's really interesting question we've had coming in, which I think plays into the second part of what I really wanted to talk about. And it's something I mentioned in the introduction, which is about what you can do with this logically afterwards, is kind of building court cases against polluters. Somebody's asking, can we legally blame the EU for climate change and prosecute them have you ever heard of successful climate-related lawsuits? I don't think that has been a successful lawsuit, but there is the case of a Peruvian farmer called Saul Luciano Liuya, who's basically got a court case that's ongoing since 2015 against RWE, the German coal producing company, related to the threat of climate change, meaning that the glaciers behind where his farm is could collapse, flooding his land. And that court case is actually still ongoing at the moment. Who wants to talk about this? Because it's a fascinating kind of whole new Pandora's box of possibilities that could be opened if we can manage to make these links between events or single events or threats and climate change, and then the people who are responsible for climate change. Sonia.
Yeah, I think that's actually an important topic, and we see more and more that actually climate questions are coming into courts in different ways. I mean, that's one possible way, is assigning blame, so saying who is responsible in the end for the emissions we have had, and basically what are the consequences of those emissions, because there are basically damages. Somebody has to pay for this, and so it's establishing basically this liability for the emissions we have had in the past. As mentioned, several cases are still going on in court. There is also a case, there was a case in the US, young people also suing, basically in the US courts about the risks they are going to have in their future. So sometimes it's about past events, or it's about the future events. And attribution.
How do you establish the causal link between somebody selling somebody some coal and a farmer feeling threatened from the glacier that's up the hill from his house collapsing and flooding his fields? How do you kind of create a link between those two things?
Well, you know, for instance, if you take this specific case in Peru, that yes, there is more risk of glacier lake outburst flood because of the increasing warming. And then we know that RWE has been responsible for some of the emissions because they sold the coal. Now, the decision itself needs to be taken in the court. I think it's not for a scientist to say what would be a fair decision, because it's also dependent on the law that is available there. But there is a link of causality. That's the whole point of the attributions. It's exactly what it is about. It's about saying, well, we have emissions that have taken place. They have led to a change in climate. This change of climate leads to some increase in probability of certain events, and these events have impacts. So the link of causality is exactly what attribution is about. How you use this in court, I would say that's more of a legal question. I was actually at a workshop from legal scholars about 2 weeks ago, where it was the whole topic was about, how do you frame this legally? I think also for people, for lawyers, it's not so clear. Maybe how do you use this information the best way in court? Because there are different ways it could be used.
Would somebody else like to come in on this, because it's a real hot potato, Sam?
Yeah, I'll have a stab at it. So for me, it's the proverbial straw that broke the camel's back. So we can quantify in terms of historical emissions which countries have put in approximately which proportion of emissions in the atmosphere. But in terms of figuring out that 1% did this damage, no one can ever do that, because the atmosphere is enormous, right? And once the carbon dioxide and the methane are in the atmosphere, it's there, and we live with the consequences. For me, the more interesting question is the intergenerational question. So all of this is about historical emissions and emissions that we're creating right now, and it has implications for the world that we're leaving the next generation and the generation after. So, will there be coral reefs? Will there be people living in the tropics? We know the tropics and the global south is much more vulnerable to climate change than where the emissions have come from historically. So what are the implications for the global north to support the global south and improve their resilience to a changing climate? For me, that's the much more critical question of how can we encourage political decision makers to act now to reduce that vulnerability, to ensure there's climate equity as much as possible across the globe. So it's not about blaming, but ensuring that people, regardless of where in the world, are as safe as they can possibly be, and we're acting as quickly as possible. We have the Paris Agreement, yet we're not on track to limit emissions to 1.5 degrees. We're already close to 1.2 degrees of global warming. So, and every single fraction of a degree matters. So every time we go to an international conference, it's really critical that the political leaders are listening to the scientists, and that the scientists are speaking very, very clearly of what the science is saying. And that's why this week it's so important with the IPCC synthesis report. The science has never been more clear. The visualizations have never been more clear of what humans have done to the atmosphere and what the implications are.
I agree. It's I was reading it last night, and I think about 10 o'clock I just had to give up because oh my goodness, it's pretty heavy going, and you just think, what have we done? But Sjoukje, I'm wondering to what extent these moments about looking at attribution, to what extent is that useful to this loss and damage type conversation that Sam's talking about, which I'd always assumed would be just done on with a much broader brush, that you would say this country did this amount and so they should pay this much.
Yeah, I don't think that our studies can be used straight away to really define a number or an amount of money that should be given to a specific country. But I think it is important to realize whether climate change did play a role and whether we should actually help them. And we shouldn't indeed, as Sam just mentioned, forget about the fact that some people are simply more vulnerable to these kinds of extremes. So an example of a recent event, a flooding in Western Africa. So it wasn't actually a really extreme event, this flooding event, but climate change did play a role there. And even that wasn't that much. I think we concluded that such an event is now 2 times more likely. But on top of that, the poverty rates are really huge, and there were a lot of socioeconomic factors. And actually, they should probably also improve their water management to reduce vulnerability to this seasonal rainfall. So it's really that we are hitting the most vulnerable people. And I think that's the main problem, that on top of their vulnerability, they have also to deal with climate change.
We've got another question that's coming from Bram. Thank you for the questions. He's asking, to what extent is the attribution approach you're using standardized, and to what extent does it have to be kind of tailor-made for each case?
Well, we have now with world weather attribution, of course, we do these rapid studies, and we use always the same protocol. So in a way, it's always the same. However, every time we start with the event definition, and that's really tailored to the event, to the impact that happened. And we discuss this with local people because they know what happened on the ground. So in that sense, every study is really tailored to that specific event.
That's interesting. And that must be taking up a lot of time to do that, actually. Yeah. I mean, resources, yeah.
In fact, the event definition itself takes, well, sometimes up to half of the time.
I'm in Europe. I mean, we're in Europe, and Euronews broadcasts to Europe, and I'm wondering about what the reaction is that you're getting to this kind of work. Let's take the case of Germany, Frank. Let's bring you in on this one. Are there conversations happening with politicians, with decision makers, saying, okay, look, X happened, it has the fingerprints of climate change on it, it is 30% more likely, or it is 10 times more likely, or whatever. How does those conversations go with the politicians, and what kind of action happens afterwards?
If you look back to this flooding in 2021, we had a lot of government people and administration people asking us, okay, climate change had changed the intensity and changed the possibility. What amount, or what can we do as a politician or person in the administration to say there's in place you cannot build a house anymore, or whatever? So they're asking us, what are the changes due to climate change? They are asking not only us, they are, for instance, asking the hydrologists to say what water you can expect if you have houses onto the border of each river, or if you can make the river wider. So they're asking us for the change due to climate change, and they're asking the hydrologists to say what amount of water you can run through the river if you have the river in one kind or another kind. So after an event, or even for a heat wave event, the people come to us, they come to the Met Service and ask what is the change, what they can do.
I suppose the difficulty we have is imagining what we've never seen before. At the start of this year, I interviewed Valérie Masson-Delmotte, who's one of the top people at the IPCC, and she was saying that the summer of 2022 in Europe that we had last year was exceptional. It was a record breaker, but that is a normal summer 15, 20 years down the line, probably. To what extent is it difficult, actually, to get people to think about extremes and to think about how far things could go? Because, you know, we thought we'd seen the worst of it, I suppose, with things like the floods in Germany. We thought, surely this can never happen again.
Shall I? Oh, no.
Yeah, Sonia.
Yeah, I just wanted to mention that there is a new area of research which is called storylines, which go a bit in this direction. So the idea is, for instance, is to look at an event that has recently happened and look at how this event would play out if we had even higher warming. And so we can try and develop these storylines for the general public to help them understand what is going to happen. Because indeed, personally, I find that this is the most challenging part. That, I mean, we have a lot of information, and to some extent, a lot of those events which are happening, which are very striking and people are shocked by, they are not really surprising to us as climate scientists. I mean, they are consistent with what we have, in climate models for the current climate. But it seems that, the general public has a lot of issues with anticipating this. So definitely maybe working out communication more in terms of presenting example of events that could happen. That's something that can help for communication.
Sam?
Yeah, so I think narratives and storylines is a really critical component of this, as is policy coherence. So we saw last year for Europe, it was the warmest summer on record. 2021 was also the warmest summer on record until 2022. So we don't know what to expect this year. We also know that there are large global oscillations. So many of the audience will have heard of La Nina and El Nino. So we've been in a triple dip La Nina, which has a cooling effect on the global environment. And we're transitioning now, or this year, into a probable El Nino state. We don't know how quickly that transition will occur, and we don't know how severe the El Nino transition will be. But the probability is that this summer will also be very warm, and next summer may be even warmer again. And we can expect, unless we cap those greenhouse gas emissions into the atmosphere, that we'll continue to get stronger and stronger summer signals where we do have these compound and cascading extreme events, where we're leading to more heat waves, more fires, more droughts, and the implications of all of those at the same time are really challenging for society to deal with. So again, it comes back to this adaptation and recognition of, are we fit for our current climate right now? Is society resilient for our existing climate right now? Arguably no. So what do we need to do to ensure that our society is fit for purpose for our future climate, which until we cap those greenhouse gases is only going to go in one direction, and the science is very, very clear on that.
Jakob, can I bring you on this? Because when we were talking last week, I think you were saying that when you get to situations where you've stretched emergency services to breaking point or beyond, there aren't enough resources to deal with things. That's when you can actually start to have conversations actually with governments about the resources they need to deploy with the problems. Can you talk to us a little bit about some of the thoughts that you have related to that?
Yes, yeah, thanks. So, I mean, again, if you talk about this event last year or the current drought in France, I mean, if you're a local water facilitator or like have your local water system, if you're on drought, maybe you ask your neighbor to borrow you some water. But if your neighbors and your neighboring country and the entire Europe is also on drought, it's hard to share resources. Similar effects we have when we have wildfires in many different countries in Europe at the same time, and we can't share like planes to fight them, for instance. I think we had this case a few years ago with like Sweden and Greece and maybe Portugal and so on. So you actually looking a bit
everywhere
into
was
our,
on fire and nobody had enough planes, basically. Yeah.
So this is we are stretched in our emergency response. So if we actually know that these events happen in the future in our simulations, we could plan for those also.
Do you think the attribution studies help a lot with starting that conversation?
I think so, yes. I mean, we haven't really done attribution studies for these type of events, but hopefully soon.
Can we, I mean, attribution is obviously going to be retrospective, but can we get to the point where we can sort of do a kind of a forecasting on something, say, you know, we know there's a heat wave coming and it's going to be this much worse because of climate change?
Yes, that's the storyline approach that Sonia just mentioned for events that we can imagine. What is much more difficult is to come up with events that haven't happened in the past. So where you would like to visualize events that simply haven't happened, but that we believe might happen in the future.
Another question that we've got coming in. So how does the panel reconcile the model's predictions with actual observations? Anybody want to have a go at that? If you've got record snow, record ice, you've got record rain, or you've got something else, you might have difference between your models and what you actually see in your observations.
Yeah, so in the typical attribution approach, for instance, the one that is used in weather attribution, and Zjoukje can also comment to this, there is always a combination of evidence from observation and evidence from models. So it's an integral part of the assessment to look both at the trend in the analyzed event, in observations, and in the models. And then the final assessment is based on the combination of both. And it's also assessed whether the models are able to capture the observation in the past, and some models might be removed if they don't perform very well. So I would say, it's an integral part of the assessment. It's certainly not ignored.
And I guess we're all constantly updating our models, right?
Yeah, and we shouldn't forget that, well, sometimes we start maybe with 50 models, and then we end up with only 20 models because the rest we threw away because they were not fit for purpose for this specific event, for this specific location. So we do validate the models before we actually use them for the analysis.
I'm interested in your view on this storylines approach that we're talking about, and which is in that IPCC report, is talking about trying to tell the stories of the future climate. What do you think about that, Sjoukje?
Yeah, I think this is really interesting because, well, especially for this communication, as said, if people didn't experience something before, then it's really hard to, well, know what will happen to make sure that people will understand it. So the storyline is one of the tools we can use for that, I think.
How do you deal with criticism of it, of people are going to say you're exaggerating? How do you deal with that?
Well, I can answer this point. I mean, if anything, if you look at the past science, actually, it seems rather that what we are observing now is on the higher end of what models were showing. So if anything, I think if you look, for instance, at the R5, it was rather a conservative report. So I don't think the climate community has a record of being alarmist, in contrary.
No, but I'm thinking about this storylines approach and about whether or not that could be interpreted by some people as sort of, you know, the use of the word story, perhaps, that it's a fantasy of the future and not a reality.
No, I don't think it's a fantasy, but it shouldn't be the only information that is provided. So it's an illustration of statistics. I don't think you should replace all of the climate science that we do in terms of providing statistics of what we expect in the future, but it's an illustration to convey, you know, what type of situation we could be facing. So you just have to distinguish the two. But actually, I would answer this that, for instance, in economy, it's often used. And so it's actually a tool that is used in many other fields. And it's rather new in climate science, but it's not that new in politics and in economics. It's very common there, actually, to think of this type of worst case scenario and think, are we ready to this? It's actually an integral part of testing your system, testing your resilience.
Frank, I saw you nodding.
Yeah, but the storyline is also help us to communicate, because you have a story you can communicate with. It's not only the science, it's also a story where you can build one step on the next one. So storyline is an approach we will do more in the future, but currently we are still working with the probability stuff, but we have to move on to the storyline.
And I guess it helps you with the engagement with the public, with the journalists,
Yeah.
with the politicians as well, because you've got narratives that they can all understand. Sam,
Yeah.
I know you were in Brussels last week. How is it at the coalface attempting to interact with politicians who get distracted by many other things?
So, well, I actually came back last night, and it was really interesting, actually. So on Tuesday, I was in a meeting with all of the IPCC working group chairs. So Valerie, Hans-Otto and Jim were there. We had two ministers from Belgium, the Minister for Climate and I think the Minister for Science and the Transition. And both of them were just like, we understand the science. Why are you talking to each other? Why are you having a scientific conference? How do we create change amongst society? And then the next day, Commissioner Timmermans was there. The chair of the Environment Committee from the European Parliament, Pascal Canfin, was there, and they were talking about what they observe. And again, the science is very, very clear. Where I think this narrative and storyline approach is really important is people get lost between the variability versus the overall trends. So, we're in the northern hemisphere, we're in winter, which means, temperatures are cooler than they are in summer. And there's been record snowfall in California, but the European Alps have received approximately half of the snowfall they expected this year. So there's always variability in the system, right? And what is really important is to maintain the evidence base of these long-term trends, and variability is a natural part of our planetary system. So don't get caught up in these narratives about the variability, but instead, and I think this is where the synthesis report is really, really useful. I've got on my screen SPM 6, where it shows the potential future pathways, and that's where we're always at a decision point if we know historically what's happened, but we have the ability to change our climate future. And to do that, we need action, and we need the politicians to agree with each other on what that action looks like, to make sure the health implications are taken into account, the mobility implications are taken into account, and that there is equity between the global north and the global south, because we know there are parts of the world that are much more vulnerable. Even within the north, there are parts of society that are much more vulnerable. So how are they protected from future climate impacts? And we have the knowledge. So it's not a knowledge gap, it's an implementation gap.
Yeah, absolutely. It's fascinating talking to all of you about this, and I hope that people have learned a little bit more about this and what's possible and what's not possible, how it works a little bit, and how the narrative of all of this is going to change in the future. Yeah, hopefully people will look online and look at some of the other conversations we've had as part of this series of Lives for Climate Now, because we've talked about the energy sector, we've talked about extreme events, we've talked about droughts and fires, and a lot of those things will feed into this conversation that we're having now. And I think it's very vital and important. And everybody, please have a look at the World Weather Attribution website. It's fascinating, full of amazing facts and figures which you can quote over the dinner table, and also have a look at the executive summary from the IPCC, which is meant to be digestible for people like you and me who didn't study science. I did promise at the start of this live, before I say thank you and goodbye, that I was going to show what I thought was possibly the cutest example of adaptation that me and the director Mathieu have ever seen, which we stumbled upon while we were looking for videos. And it does involve a sea otter, which is one of my favorite animals. And I just kind of wanted to show you this because it's super cute and it's going to lighten the mood. Mathieu, let's see if we can make that come out on the video. There we go. That's adaptation to the heat waves. That was from 21st of June, right in the middle of summer. They were having a nice time, weren't they? Told you it was going to be cute. But anyway, thank you everybody for this really fascinating conversation. It's been great. So thank you to Sonia Seneviratne, Professor for Land Climate Dynamics at ETH Zurich. Thank you very much to Frank Kreienkamp, the head of the Regional Climate Office at the German Weather Service, DWD. Dr. Sjoukje, researcher in climate change at the Dutch Weather Service, KNMI. Dr. Jakob Sjoukje, group leader in the Department of Computational Hydrosystems at the Helmholtz Center for Environmental Research. And Dr. Samantha Burgess, Deputy Director of the Copernicus Climate Change Service. Thank you very much, everybody, for being with us on this Climate Now Live. Please have a look at euronews.com/climate now for the latest information on how our planet is changing with the latest data from Copernicus and reports from all around Europe. I've just been up to the Arctic to actually film a story about how the Arctic is changing. It's very fascinating, very interesting stuff. So please head over there to have a look, and have a look at euronews.com to follow world news from a European perspective. Thanks for being with us.